Now we're going to prove trig identities by factoring. When you look at the left-hand side of this equation, tangent to the fourth x plus tangent squared x, compared to the right side, secant to the fourth x minus secant squared x, one side isn't messier than the other side. So you can choose to work with either side of the equation. I'm going to work with the left-hand side of the equation, and we're going to try to get it to come out to be secant to the fourth x minus secant squared x. In looking at tangent to the fourth x plus tangent squared x and thinking about how can I get them to be secants, you want to think about your Pythagorean identity, which says tangent squared x plus 1 is equal to secant squared x. So when I look at the left-hand side of the equation, I need to first factor out a tangent squared x. So when I take tangent squared x away from tangent to the fourth x, I'm left with tangent squared x. And when I take tangent squared x away from tangent squared x, I'm left with 1. Well, when you look back at your Pythagorean identities, tangent squared x plus 1 is equal to secant squared x. So if we replace tangent squared x plus 1 with secant squared x, then I have secant squared x times tangent squared x. Now I need to get tangent squared x out of the equation so that I'm left in just secants. So if you go back to your Pythagorean identity, and I subtract 1 from both sides of the identity, I get tangent squared x is equal to secant squared x minus 1. Now we can go back and replace tangent squared x with secant squared x minus 1. So here I have secant squared x minus 1 times secant squared x. If we take secant squared x and we multiply it into parentheses using the distributive property, now I have secant to the fourth x minus secant squared x. And when you look at the right-hand side of the equation where we were trying to get to, we've now proven that tangent to the fourth x plus tangent squared x is the same thing as secant to the fourth x minus secant squared x.